Hello once more. Welcome back. Today I would like to continue on my bare metal project. Uh, Thank you for all the suggestions and things to deal with, just things to do in the videos. Uh, don't hold your breath though, there are a lot of them, and for many I have honestly no idea how that would work, or I need to order hardware. But anyhow, today I wanted to add an HTTP client to the embassy. It was a lot harder than I thought. It really feels like something that should be trivial, and while once you know how to do it, it's not that difficult. But yeah, it's still a lot of work to figure it out, and I need to really dig deep. One thing would like to do different today is that normally I try to code from principles, so just from starting it and just adding what we need to add, and that I also for myself that I know why I add it and why I add dependencies, and I tried that, and that just doesn't really work in this particular space. Uh, Basically, the only documentation I have how to do this are examples that are have a little bit of documentation, but generally they are just examples. And all the code I see out there are based on those examples. So I'm going to do that too. There's no point in me trying to explain why I add code while in reality I just add it because the example says it needs to be there. And also there's a lot of, especially in the dependencies, there's a lot of really finicky dependencies that you need to get exactly right. And there is no way to figure out what that even means until you try. And it's also pretty dynamic. There are a lot of unstable features. So yeah, that's not going to be very useful to do that because I'm not sure, and also probably within months or even weeks it will be out of date and will be different. So what I want to do today is continue our project from last time. I back then we commented out the Wi-Fi integration because we were just doing the introduction to the embassy, the async runtime. So I'm gonna add that, and then I'm gonna follow the embassy Wi-Fi example from the repository and just add what needs adding there. Um, so yeah, it's mostly boilerplate. It's not particularly interesting. I mean, I can't imagine that there's a lot of customization there, but yeah, let's go. So starting here, where we had this piece of initialization of the Wi-Fi, which you commented out. Probably we have a timer, we have an init, etc. Let's have a look at this example. So this is in the Esp-Wifi. There are some examples there for different boards, and this is what we're looking at today and what matches our situation is embassy DHCP. So it's not like an access point. It will connect to a Wi-Fi router, and that's what this one does. So a lot of stuff is quite similar that what we did. So we started. So we had the timer group with the Esp-Wifi and the get the radio. That's I think all in here. No, not just yet. Yeah. So oh yeah, this is in here. Initialize. Then we take the radios and yeah, let's add this in here. I will need to add semicolon there. Need to rename this, I suppose. Where does the unwrap come from? Okay. I mispasted. Fix some imports. The Wi-Fi mode. So we have a timer group. We already had a timer group. I think we can just use the same one if I'm not mistaken. So we don't need the same one, right? Yeah, I think we don't need this one. Going on, then initialize the embassy thingy. I think that we already do, or we already did. Let's keep the order, so I'll move this up there before we initialize the embassy. From there, yeah, sorry about flashbang, the widescreen. Is there a dark mode for GitHub? I'll look it up for the next time. Sorry. I got some complaints about white backgrounds. Moving on. So this is yeah, and then we create a configuration, DHCP configuration. That will probably not work out of the box because we have a lot of configs, but not the one we're looking for. What we need is we need to add embassy net. So let's do a cargo add embassy net. And there are a bunch of features, and I think we need a lot of them. We need this one. Let's add DNS. I don't know what this is. Let's add log. Pretty sure we need Ethernet. I don't know why, but it doesn't. When you omit it, it won't work. This one too, I think. Nightly too. And yeah, I have no idea how to really know these things. TCP and UDP. Without UDP it also doesn't work. And the unstable trade. So hopefully in the very near future, a lot of those. This will make a bit more sense, but it is what it is. Alright, so now we should be able to make this one work. Yeah, now we have the embassy net config. Alright, let's continue with initializing the network stack. So we need the seed, we need to create the stack. Yes, this is the singleton macro. For the singleton we used before, I kind of used the static cell manually because in like educational things I don't really like to use all the macros, or at least too much. So, but it uses this one. It's just inline, so I'll do that for now. I'm not super down on what's in here, but I'll just add it, and that should shut this part up, and then fix some dependencies. I mean imports. So it says that the trade bound isn't satisfied. I think that has to do with this one, with ESP32. Wi-Fi because I think it needed, yeah, because the way it works now, ESP, Wi-Fi, and Embassy are actually kind of tightly coupled in the sense that you can't really see them as a one-way dependency because, like, for example, Embassy needs to respond on network events, and for that there needs to be some kind of interface between the two. So I think we need to add Embassy here. Embassy net, I'm not sure. And we need to add Async, if I'm not mistaken. I think it was Embassy net. Async. Let's see what that does. Add some. Okay, that seems to do something. So that resolved this problem. Yeah, so this is some version that was created by the template in our case in the last episode. So I'm not sure why this one is special. If I go to the latest on master, it doesn't work. And probably you can make it work somehow. But yeah, don't underestimate that because I wasted so much time in trying to get it to work with the latest version or with the published version. So do that only when you have a lot of time on your hands. Anyway, we have a stack. So actually the network stack is now kind of configured, but not really up. Because if you think about it, that in itself is also an asynchronous thing. It takes time to power up the modems and to connect to Wi-Fi, to get DHCP IP address, etc. So that's also a async job, which we'll need to add. So back to the brightness. There is where are we? Yeah, so there are some tasks here. There are 3. Connection. I suppose that's because you create a connection. There's a network task. I'll get to that in a moment. And there is a nicely named task called task. And that's actually doing something with the stack. So let's start with this one, the connection. So I'll go through it quickly. Probably need to fix some thingies. Let's put it up here. So this task is in order to initialize the Wi-Fi, the Wi-Fi connection. So I need to fix some of the imports. This one, I think. I think I might have imported something wrong. Because there is. It looks alright. Let's see if we fix some other things. Wi-Fi config. Oh yeah, these. Watch your eyes. Just from the environment, like I used before in the ESP IDF things, the same thing, bound to some environment variables. Let's see what's wrong here. So I need, okay. Yeah, that helped a lot. Okay, so this is async task. I need to annotate it as such. So let's, so we need to add that one. Spawn connection. Yeah, I guess controller, I suppose. And then unwrap. All right, so that will also schedule that one. And note that all these 3 tasks run independently. All right, move on. And now we get to this funny one. And that's, I'll put it here. So this is the actual task to make the network do anything. Because even, yeah, the network, any network activity that needs to run somewhere, right? And if you don't add this one, there won't be an error, but the network stack will simply not do anything. So the only thing this does is just enable the stack so that the general state machine of the stack keeps moving. So let's add that one as well. Spawner, spawn net task with the stack and unwrap it. Let's see. Seems okay. And then we have the final task, called task, that will actually do something. In this case, it will do a HTTP request, but like with manual TCP implementation, which is kind of hardcore, but honestly, I'm too old to do that manually, so I'll have a look at Embassy, which is an HTTP client. But let's first have a look at this thing. So it starts by creating some buffers. It doesn't really need them right now, but important here, because all the jobs start at the same time, right? It's not like an ordering. It will need to check if the stack is working at all before doing anything, and if not, wait for that to be the case. When it does, it needs to check if it got an IP address from the DHCP server, because even if there is strictly speaking, on Wi-Fi, on transport level, there is a link, doesn't mean you have an IP number. So these checks you just need to do, because otherwise it will just straight up try to do something over a network that hasn't been initialized yet. So that's all fair, all fine. Then there's a pause here for some reason. I'm not sure if it's necessary. And here stuff is happening. So yeah, we can go quickly through this code. It's not complicated. You create a socket, a TCP socket, just a regular one. Add a timeout, why not? Create a endpoint, so where we want to connect to. I'm not sure whose IP address it is. I think it is public, but I'm not sure. It will try to connect, await that, and then simply write the HTTP GET over the socket, write the enter file, and then read this response, I suppose, and then and then print a response. So for something that's super basic, that's okay, but for anything even slightly more complicated, you want something more yeah, so something a bit more mature. So let's remove this part. Let's see. From here, I suppose. Yeah, let's do that. So here we have established that we have a network connection, and now we can do something. Okay, so for this we need to add something, and what I wanted to add was something called Reqwless, which is a variation of the very popular create request with a weird spelling as well, but embedded with no standard. So you can create a client, and from there you can basically do simple HTTP operations. It supports TLS as well. I don't think I'll get to that in this one. But yeah, so you can use it as a pretty much the same way as you would use something like request. And that's a whole lot nicer than hand coding it over TCP connections. So on crates there are a bunch of versions. From experimentation I know that this one works. 060. The later ones require something that's incompatible with the current version of Esp-Wifi. Not really easy as far as I know. Let me know in the comments if you know better. There is not really a easy way to figure that one out, to know that one. But let's go. Cargo add Reqwless. Let's add the alloc and the log as well. Who knows? We have alloc anyway, and logs might save your butt at some point. That's in, I forgot to specify the version, so now it's on 8. We have to go to 6. Alrighty. Let me check. So, as you could see in the example code, you can create a client and you need to supply it a socket implementation, so something's capable of making connections, and a DNS implementation. So let's do both of that. For that, we'll need to do, you guessed it, some boilerplate. I'll just do it in the loop here, which is a bit weird, but let's just start there. So we want to start with creating a TCP client. So that's a embassy object. We need a stack. We have a stack, and a state object. I think it needs to be borrow, and the state object. That is something that will keep the state of the connections, because most of these embedded crates don't want to allocate memory themselves. So in order to be able to operate in any kind of capacity, you need to pass it to them then what memory to use, because you need buffers, you need stuff. So for that there is a struct TCP client state, and that client state is this. and that needs some generic parameters. One of them is the size, and the size is the n is the number of concurrent connections. So as we're not being like single threaded, multiple connections can be in flight. There is a transmit buffer size, and there is a reading buffer size. So let us see. That's something like, I think we need to turbo fish that a little bit. So, and we need like, let's get this out of the way so we get some decent feedback. So let's go with, I'm really not that sure how much memory we should take here. 2048 for both, something like that. That made this one happy. Pass this one in here. TCP client is this one, and that's probably mutable, or maybe at least a borrow. Okay. Voice is bad. Other thing, we need the DNS thingy, right? So DNS socket, new. Need to pass in the stack. I think that's why we need UDP actually. Now I think of it. That makes sense. Okay, so now we have TCP client and DNS. So let's now see if we can actually make a HTTP client new with the TCP client and the DNS. Probably a lot of mutability issues. Am I wrong in this? Weird. That error message didn't really make sense. I don't know. Okay, so here we go. We have a HTTP client now. I'll continue just doing it one statement at a time, so we have a whole ugly bunch of let statements, but at least then you know where you are. So let's create a request. HTTP client, I suppose. Request method get. I am running locally a container with SurrealDB. Doesn't really matter. It's something that can can serve HTTP. So I got it on 10.11.12.112 port 8000, and I just asked the version, something as basic as it can get, and it says something. So this is the URL we're going to access. So that this is on my local laptop, not on the controller. And let's go with that. So we add the URL here. Just to be sure, let's add HTTP. Mutable, yes. So now we have a future, so we need to await it and probably unwrap it as well. Yeah. So now we have a request object. Cool. Then let's get a response. Send the thing, and we need to create a buffer for that. Okay. There was one here. I think we can use this one. Should it match in size with this one? Not sure. Let's do that. So we used our X buffer here. Is that correct? Yeah. Or we need to borrow it. And that one should be mutable as well. That makes sense. And there we need to await it and wrap it. So now we have a response object. Okay, let's show if it kind of worked. So first let's print status result response status. I think that implements debug, pretty sure. Status object. Yeah, it has debug, so I can just print it here. And let's extract the body. Response dot body read to end. Await, probably unwrap. Let's see what we have here. We have a byte array, so let's create, pretty sure that's a string. So from UTF-8 we do this, and then we unwrap it again. Now we have a string slice. So let's print that too. Body and body, and then yeah, so some weight would be nice. Okay, yeah. Oh yeah, now I need to still add it, of course. So it still has the silly name of task. Oh well. Spawner dot spawn task with the stack. And unwrap it. Okay. Let's see if that works. I haven't set up my desk. My desk is a mess, and also it's not very visual, but it's right here. It still has the annoying blinking going on. So here we are. Cargo, ESP, flash. Thing. Flash. You definitely need to do it in the release mode. If you don't do that, you get super weird error messages, illegal access, things that don't really make a lot of sense. And it's really, yeah, it took me a long time to figure that one out. I was sure it worked before, but before I was building with release, and then I forgot at some point, and then it all fell apart. So release is important, and we can do this as well. And do this. It's getting quite a bit bigger now. Now the entire network stack is back in business. So actually the amount of size we've gained, or space we've gained by having a smaller binary, is not as big anymore. But yeah, it does do a lot of things. That seemed to... It's still blinking, so I think it's actually kind of working, but I'm not super... Don't really trust that cable. Let's see if I just monitor. That's annoying, the loop things. Yeah, now it's getting an IP address. It got an IP address. See. So yeah, that loop is annoying. That's with is still from the lights. So remove that one. So it says link up. It got its link, and our task is still waiting at this point, right, until the link is up. It got an IP address, and then finally it did a HTTP call, and it got that same body we got when using curl. And then again after a few seconds. So there's that. It's a bit of a long one. I'll maybe do another one to add TLS. That's pretty important, I suppose. So, but I'm gonna leave it here. So thank you for all the likes and all the reactions. It makes a difference for me. So please keep on liking and subscribing. And if you have ideas or feedback, let me know. And yeah, see you next time. Bye. Alright, I'm gonna add a little bit to this video because I wanted to do the using the DNS and the TLS to use HTTPS, and it's not enough to do another separate video, so I thought I'd just add it onto this one. So where we ended up, the difference will be in where we create the HTTP client. So right here, because the HTTP client, and I think it's a nice journey to make now, also has a new with TLS. So the socket client, the DNS is the same, but there is a TLS config. So TLS config, let's see what that is. So that needs a seed, so that's probably for the random generator, a read buffer, a write buffer, and the TLS verify, and that's enum. So yeah, well, let's go for none for now, and I guess for if we want to verify certificates, we need to load root certificates somehow. It's a little bit much, I think. So so this is basically gonna be this, and we need to add one more thing then, and that is a TLS config. Let's make that TLS config is TLS config. I suppose we need a separate buffer for that. So we used the Rx buffer. I don't think we used this one, or did we? I don't think so. So let's create TLS read buffer and a TLS write buffer. And then we'll add them. Let's was it TLS read buffer. That's pretty sure it's going to be mutable borrow, and TLS write buffer, and verify will be TLS verify. No. Why did they say TCL config? That makes no sense. Okay, and then we need to go somewhere HTTPS. So let's see, HTTPS. Let's go to google.com. Let us see what that brings us. Yeah, just need to reconnect my disco machine. Okay. So I swapped out the module and the cable because of the weird flash writing errors, but I don't think it makes much of a difference. So I'm not sure what's wrong now. But now I've reduced the size of the client state because think about it, it doesn't make sense to make them the same size. So I reduced that quite a bit to 1K. Look at that. It has 301, so a redirect to www.google.com. So that's what we are looking for. I'm not sure what the queue full is, but it doesn't seem to crash on it. And you can see that if the cable keeps working, that as it is, no, I broke it. But as it is connecting and doing all the stuff, the blinking just continues, right? And from a system with a computer with an operating system, you expect totally that to happen. But from a single core microcontroller, you need to do work to make that happen. So yeah, I like that. So that wasn't super hard. Actually checking the certificates may be a bit of more work, and then you need to include that somehow in your build. So that's a bit more than I want to do now, but yeah, nice. Okay, now this time for real. See you next time.